ratios in 3 different ways that ratios can be represented are here. So the most common form that we will see, and the most useful form that we will see, is the one that's represented by a fraction. We will see that fraction more than we will see any of these other ones. However, in your problem, or whatever the question is, normally they'll put it in this form or this form, and you'll have to convert it to this one. But the most useful one for us, for our purposes of doing any kind of calculation, will be in a fractional form. Okay? So if they said there were 2 boys to every 3 girls, then I can represent it in 3 different forms. And there will be questions like that as well. It'll say, show me how to represent this ratio in 3 different ways. Okay? So now going over the definition of what a rate is, you guys have all seen that. Rate is simply a ratio of a distance to a time, for the most part. It looks like something measured, okay, something measured compared to something in time, normally. Yeah, I do. Sure. So like miles per hour, feet per second, etc., stuff like that. Okay, so we normally see it as measured distance of some sort to time. So in an example of miles per hour, we will see it as miles per hour. We could see it as miles to hours, like that, represented as a ratio. And then you can say the word to as well. Okay, now unit rate, every time you hear the word unit, you should always think 1. You should always think 1. When I say unit rate, always think 1. When we were doing conversions, we did unit conversions, and I told you that every time you think of a unit, like 12 inches over 1 foot, that's equal to 1, because every 1 foot is 12 inches, so it looks like 12 over 12. So it's always equal to 1. Now if we say unit rate, I want to know the unit rate of something. I want to know my unit rate per 1 of whatever it is that I'm talking about. So if I'm talking about how much money I spent on gas, if I spent $40 on 12 gallons of gas, then I've now set a unit rate, or I've set a rate but not a unit rate. So if I said that I spent $40 to my, let's say 12 gallons of gas instead. That's not a unit rate, and I would need to write it in fractional form. So I'd say 40 over 12, $40 over 12 gallons. And then to get a unit rate, I would just literally divide them. So I'd take 40 and I'd divide it by 12. I don't know what that is off the top of my head. So it's 3 1/3. Or 3.33, however you want to write it, dollars per gallon. So per 1 gallon. It's where the denominator is equal to 1. So unit rate, the short definition would be where the denominator is equal to 1. Okay? If you buy boxes of cereal in bulk and it's $10 for 10 boxes, that would be a ratio, and we need to convert it down to a unit rate, so we just divide it. It's $1 a box. Okay. Example 1 then. Example 1 is finding a unit rate. If it gives us which is the better buy, which is the most common one you're going to see, 5 cans for $4.95 or 6 cans for $5.75. And now this is just whatever your favorite canned food item is. Chef Boyardee is mine, so I'm going to go cans of Chef Boyardee. I would take, it's always quantity, or sorry, so not quantity. Quantity is always on the bottom. Okay, it's always quantity on the bottom. But on the top, it's normally cost over quantity. Okay, you'll see it as cost over quantity, which is pretty obvious. When I say how much gas I bought and I tell you the price, it was $2.25 per gallon, or whatever it is. Okay, so I take my cost, $4.95, and I put it over my quantity, 5, and I just do that division, and I get 99 cents a can, so about $1, right? And then over here, same thing, cost over quantity. So cost is 575 over 6. And when I divide that out, I get 96 cents. Okay, now remembering that this is dollars per can, right? So this is 99 cents per can, written in proper notation because I don't lose those labels. So this is 96 cents per can. So which one's the better deal? This guy right here. So the better deal is the 6 cans for $5.75. Okay, these are really quick, really quick. So remember, it's always cost over quantity. Now when we're converting rates, we're used to this, so I'm just going to do a quick example. If it says he drives 30 miles per hour, per 1 hour. Now we've gone over these before, but we're not real comfortable with them. I've seen on y'all's reviews. We're not real comfortable with them yet, so we need to write them out. 30 miles per hour, and then it wants to convert it to miles per minute. So luckily I don't have to change my miles at all, but I do need to convert from hours. What is my unit conversion from hours to minutes? So 1 hour has 60 minutes, right? And I have to cross my hours out so that they go away. So I'm left with 30 miles per 60 minutes. Now, in the past, that's probably where we would stay, or we would reduce it. However, we want a unit rate. I want to hear a unit rate. So to convert this to a unit rate, I would have to divide these two. And I'd get 1/2 of a mile, or 0.5 miles per hour. So now I have, sorry, minute, you're right. Minute. So we converted it to minutes. So anyways, our unit rate is where the denominator is equal to 1. So we go 1/2 mile per 1 minute. Okay? The denominator will be equal to a 1. See, that's the only really difference between what we've been doing and what we have now. The denominator will always be 1. Okay? Alright. Starting to talk about what a proportion is. A proportion is basically just two ratios set equal to each other. So a proportion compares, again, two quantities, but it compares it to two other quantities. So the way that we would normally have seen a proportion, that y'all have seen several times, is if I had 6 ninths written here, that is the same as 2/3. It's proportional because this is just a multiple, right? Or not that way, it's division, right? It is proportional to the other one. It's simply just reduced down. So a proportion would be comparing two things to each other, two ratios that end up being equal. Now that only comes in handy when we start doing our examples where we have something missing. So let's just do a flat example. On example 3, they give us x over 15 equals 2/3. Now a bunch of y'all are saying I don't need to do the cross product rule, but if you don't start practicing the cross product rule here, when it gets a lot harder, you're not going to know how to do it. So yes, I can go 3 times 5 is 15, therefore 5 times 2 is going to be 10, so x has to be 10. But I need to start practicing cross product rule while it's easy, so when it gets hard, I know how to do it. So this is the cross product rule, and most of my other classes just call it the heart because that's what you end up making. I go 5 times 2, and I make that part of the heart. So 5 times 2 is 30. Then I go 3 times x, so 3 times x is just 3x, equals that right there. And I just start doing my regular algebra. Divide by 3, divide by 3. Therefore, x is going to be equal to 10, and that's my final answer. Okay, cross product at the beginning is very easy, and you could probably predict your answer before you get there. So use that as a checking mechanism instead of a I want to do it fast mechanism. If you don't practice doing this now, it's going to be really hard when you get to a couple lessons down the road, and especially when you get to Algebra II where you're doing crazy cross products. On part B, they have already stepped up our game a little bit. X minus 1 over 12 equals 1/6. Now pay very close attention here. My 12 times 1 is easy. It's just 12. My 6 times multiplied by, okay, so I'm writing it out, 6 times x minus 1. I put it in parentheses. If I don't put this in parentheses, I'm going to forget to distribute. Okay, I have to distribute the 6. So when I distribute my 6, it becomes 6x minus 6, and it equals 12. And then I'm back to just my regular algebra. I add 6 to both sides. The 6's cancel out on my left. I just drop down my 6x. I get 18 on the right. I divide by 6 next. My 6's cancel out. My x is equal to 3. Okay, questions on that? This is the one that's going to mess up most people because we're going to forget to distribute. Make sure you do that distribution. No questions? All right. That's really the hardest part that you'll see in this. So the last example that we're going to do is example 4. Example 4 is solving a multi-step proportion. We have to learn how to set it up. So the ratio of boys to girls, so I'm going to write that down, boys to girls, just like that, is 3 to 2. So now I can write my actual proportion, 3 to 2. The class has 25 students in all. How many boys and how many girls are in the class? So if the proportion is 3 to 2 for boys to girls, we need to write the proportion for what it is for total students. So if we're looking for how many boys and how many girls there are, we just got to break it down into 2 pieces. So the ratio of boys to girls was 3 to 2. What is the ratio of boys to the whole class? So it'd be 3 to 5. So I'd add these 2 together, I'd get 5. So boys to the class. So boys to the class. So it's 3 to 5, right? And then as I'm setting up a proportion is a ratio compared to a ratio. This is total, my whole class. So what is the whole class? 25. And then I don't know what this is. I'm going to give it x, or I could give it b, whatever you want. Let's use b just so we can change it up a little bit and you get comfortable. So I'm using b, and now all I have to do is the cross product rule. So 5 times b, which is 5b, 25 times 3, which is 75, and then I'd put my equal sign down there. Divide it out by 5. 5 goes away, and I'm left with b being equal to, what is that, 17? 15. So there we go. So there are 15 boys, right? So there's my answer for boys. Now I have to do the one for girls. There are 2 girls for every 5 total students, and this is going to equal a total of 25 students on bottom and an unknown amount on top. That's girls. So again, just cross product. 5 times g is 5g equals 25 times 2, which is 50. Then I just divide out the 5. And number of girls equals 10. So I have 10 girls and 15 boys. When I add those 2 together, I get 25. So that's a quick way to check. And I'm actually done. Okay, questions there? Nada? Okay, I just know we're going to have a question like this, so I'm just going to go ahead and do example B on 4. On a map, Albany to Jamestown measures 12.6 centimeters. Jamestown to Springfield measures 9 centimeters, and you should draw this picture while it's there. And Springfield to Albany measures 4.75. What is the actual distance from Albany to Jamestown and back to Albany? What is it asking us to do? But what is it asking us to find? What is it asking us to find? The actual distance from, right, to make the whole triangle. So what is the distance that makes the whole triangle called? It's asking us to find the perimeter, right? So I need to find the perimeter first. So it tells us the measurements of what they were. It was 12.6. And how do I find perimeter? Add up all the sides, right? So 12.6 plus 9 plus 4.75. So I have to find my perimeter first. When I add all those up, I get 26.35 centimeters. So now there's a unit conversion here that I have to follow. It says that the scale on this map, notice it gives it to us in a ratio, is 1 centimeter to 25 kilometers. Consider this kind of like a unit conversion. Okay, it can also be written as 1 centimeter over 25 kilometers, or I could write it the other way, 25 kilometers per 1 centimeter. Okay, I can write it any of those ways. Now, let's start to follow what we need to do. I have 26.35 centimeters that I need to convert to kilometers because there is a scale on this. So this is just over 1, right? I need to get rid of my centimeters. So I need centimeters to be where? On the bottom, right? So my 1 centimeter goes on the bottom. My 25 kilometers goes up top. And then I can just do my multiplication. So centimeters go away, and I multiply straight across. 26 times 25, which is like 658.75. Okay, and then that's in kilometers now, right? Kilometers. So that's one way to do it, but there is another way with a proportion. I'm going to show you here in a second. But that is the easiest way that y'all guys probably should be most comfortable with. But there is another way. If you wanted to do it as a proportion, which you absolutely can, we would set it up. We know this unit conversion, 1 centimeter over 25 kilometers. We know it's going to be equal to the number of centimeters we had, which was 26.35, over an unknown amount of kilometers. So we're going to give it x. And then you just do cross product and solve it just the same. And you'll end up with the same exact answer because look, 25 ends up multiplying by 26.35, just like we did here. Okay? So you'll end up with the exact same answer. X equals 658.75 kilometers. Okay? The most important thing that you can remember from this is that we always set up our ratios the same. If it's centimeters over kilometers on the left, it better be centimeters over kilometers on the right. If it's big to small, then on the right, it better be big to small. However you set it up, it doesn't matter, but it has to be the same on both sides. Questions?